Hi, this is Alex from devstories.eu. DeepEval Framework, Episode 14 of 18. In complex autonomous agent workflows, you do not always know what the test case should be until the agent actually starts executing. You cannot write a comprehensive static test suite for intermediate decisions that have not been made yet. Dynamic evals at runtime resolve this limitation by letting you construct and evaluate test cases mid-flight. Typically, developers define static test cases externally. You create a file of rigid inputs and expected outputs, then run your application against them. That approach breaks down when dealing with autonomous systems. When an agent receives a prompt, it might route the query, select a specialized tool, and generate its own internal search string. Those intermediate inputs and outputs do not exist until the code is actually running. Dynamic evaluations abandon the external file. Instead, they build the test case step by step as variables populate inside the active application. Consider a targeted scenario. You need to evaluate context precision inside a deeply nested retriever function. You want to test just that specific mid-flight step, isolated from the final output the user sees. To do this, DeepEval provides two specific functions to intercept execution data: update current span and update current trace. A trace records the entire lifecycle of a request, from initial user input to final response. A span represents one specific operation inside that trace, such as your retriever function. When that retriever function executes, the dynamic variables finally materialize. You now have the exact search string the agent generated and the specific text chunks your database returned. Right at this moment, inside the retriever logic, you call update current span. You use this function to intercept those live variables and map them directly into a new test case. You take the intercepted search string and assign it as the test input. You take the raw database chunks and assign them as the retrieval context. You have just constructed a golden test case during execution. Because you built this golden dynamically inside the span, you can immediately evaluate it. You apply your context precision metric right there. The metric runs against the live data, scores the retriever step, and attaches that score directly to the local span. When you review your traces later, you do not just see that a retrieval happened, you see a highly targeted evaluation of that specific retrieval based on the exact conditions of that run. That covers granular steps. Sometimes, however, a nested operation uncovers something that changes the context of the entire request. This is where update current trace becomes necessary. While update current span modifies the local step, update current trace allows a deeply nested function to reach up and modify the global execution record. If your agent discovers information mid-flight that completely changes what the final answer should look like, you call update current trace to update the expected output for the entire run. This keeps the global evaluation aligned with the live, shifting reality of the execution logic. Here's the key insight. Moving evaluations from external files into the runtime execution tree turns testing from a post-mortem exercise into a live diagnostic mechanism. By binding metrics directly to spans as they execute, you stop guessing why a multi-step agent failed and start measuring exactly which internal handoff caused the failure. Thanks for listening. Happy coding, everyone.